This is 22 through 24. Consider this recursive definition. We're given the fourth term. We're given how to find the next term in the sequence. The initial value, so I know the fourth term is equal to 144. I also know that I can go back and find the initial value when n equals 0. So here, since I know that any term is equal to 2 times the one right before it, this is equal to 2 times whatever came right before it. So if I do 144 divided by 2, that means this would have had to be 72. If you read this and you're not sure what that actually is telling you, you can always plug in a number and calculate it as a formula. So if you plug in n equals 3 into the formula, this would tell us that the fourth term is 2 multiplied by the third term. Well, I know the fourth term is 144, and I know that I'm getting that by multiplying t of 3 by 2. So t of 3 must be 144 divided by 2. So we keep dividing by 2, we can get to the initial value. So divide by 2, we get initial value is 9. The explicit equation, t of n equals, since I can tell that the initial value is 9, I put that as my initial value in my geometric sequence, and I'm multiplying by 2 each time. What is the value of n such that t of n equals 2,304? In this case, you could just continue your table until you get there, or you can guess and check on your calculator to see when you get there. It actually turns out that the next term is 2,304, because if you take 100 and, or actually, scratch that. If you do times 2, you're not going to get there that quickly. So we're going to have some higher value of n. So go ahead and just start guessing and checking. So let's say you think it's the 10th term. That's way too large of a number. So I'm going to decrease my exponent here. I'm going to say the 7th term instead. Okay, that's too small. So I'm going to guess somewhere between 7 and 10. And it ends up being 8. So n equals 8.